Hello, welcome to this video. In this video we will be explaining the basics of distillation, what glassware you will be using, the equipment used. As a company we get a lot of questions about the basics of chemistry, distillation, glassware, equipment. So we thought it was a good idea to just make some basics video about this. So in this video we will be taking a step-by-step look on how you can perform basic distillation, and we will explain everything along the way. So the first thing we need to do is to check the size of the glassware you will be needing. It's important to always leave some spare room in the flask in case the distillation or reaction goes out of hand. It might overflow and go up your distill head in your condenser, which will ruin your end product, or chemicals might go to places you don't want them to, or eventually end up outside of the reaction, which you don't want, of course. So before we start, we have to check what kind of glassware we will be needing. We're going to distill roughly about 1 liter Perfluoro 2-methyl 3-pentanone, which we used in a previous video to submerge one of our phones into. This got a little bit dirty, so we're gonna redistill it and show you how it's done. Since the starting volume is about 1 liter, we're gonna take a flask that is bigger, in this case a flask of 2000 milliliters. So the other glassware we will be needing is the distill head, thermometer, the condenser, the vacuum adapter and the receiving flask, which we'll take a look now one by one. Alright, so here we have our 2-necked flask. Round bottom because we'll be using a mantle, and it's preferred because it heats more evenly. You could use a single neck, but this is just the one we have on hand, and we will be using this for our distillation. Next we have a distillation head. You put this on top of the flask. It has 3 joints. The top joint is usually used for the thermometer, and the other 2 for the flask and to put the condenser. Next up we have the thermometer. We use a thermometer with a ground joint, and it has the range of 250 Celsius. Always make sure when you use a thermometer that the maximum is well above the temperature of the boiling point of the liquid that you're distilling, otherwise it can snap and end up in your reaction. Next we have our condenser. It's always important to choose a condenser which has enough cooling capacity to condense all the liquids that we're boiling. Next we have the vacuum adapter. This will be placed after the condenser and on top of the receiving flask. It also has a hose connection to which we could attach a vacuum hose with a vacuum pump when you're distilling under vacuum, but we won't be doing this in this video. Next we have our receiving flask. In our case it's quite special because it has 2 walls in which between you can run cool water. This is especially handy if you're distilling volatile liquids that evaporate easily. So you can cool the receiving flask to a lower temperature, which results in less product evaporating and leaving your apparatus. Next up we have our heating mantle. Usually this is preferred when using distillation because it heats up the flask evenly. Ours also has a built-in magnetic stirrer. Larger volumes usually don't have built-in magnetic stirrer and use an overhead stirrer. You could also use a heat plate with stir bar or something like that, but the heat up time is really a lot longer than with a heating mantle. Next we have a circulation cooler. These are quite overkill in most of the reactions you will be doing. And they're also really expensive. The advantage is that you can set the temperature to what you want it to be. So for example, our circulation cooler will go to a maximum of -10. This is especially handy if you're trying to distill volatile liquids with a really low boiling point. You also have some control over the temperature as well. Next we have some clamps with cork lining. This is to not damage the glassware, and also a boss head to connect the clamp to the stand. Make sure you don't over tighten it to damage the glassware. Next we got our heating mantle. We'll be putting the flask inside of it. We will be raising the lap jack a little bit. This is done to be sure that the receiving flask will be on the right level, so we don't have to do some weird maneuvers to be able to attach it later. So now we're filling up the flask with the chemical we want to distill. We do this first because we don't want to disconnect any glassware later in the process, just so we can add the chemical to the distilling flask. So when you're assembling glassware, it's really important that you always grease the joints. If you don't do this and when you're done with the distillation, they can get stuck and it's really difficult to get out, or in some cases you can even break them. And as you know, glassware is really expensive, so don't forget to grease the joints. So now we clamp it up to make it secure and straight, and also stopper off the second hole in the flask. We will be needing a retort stand with a clamp to attach the condenser to. So what we like to do is we first put the stand, then we get a condenser, and we add a condenser to the stand and put it approximately at the same angle as the distillation head, so it's easily connected to the distillation head. So make sure, like before, that the joints are greased. Our condenser has screw tabs for the hose. This makes it somewhat easier to connect hoses in some situation, and you don't have to put a lot of force on the condenser itself to remove the hose after you're finished with the distillation. Make sure that the condenser is sealed correctly to the distill head, otherwise some vapors might escape through the connection, which is something we want to avoid. So next we will be taking a second lap jack for the receiving flask. Next we will be putting on the vacuum adapter to the greased joint. We're turning it around a little bit to make sure that the grease is on all sides of the joint so it doesn't get stuck later. Make sure the connection is sealed properly so we don't lose anything. The last thing we will be needing is our receiving flask. Again, we grease our joint. We put on the receiving flask, turning around a little bit so the grease is on all the sides. We raise our lap jack a little bit so that it's level and it doesn't move the rest of the apparatus around. Here we are moving the flask a little bit around to make sure that the connections for the hose are on the right side so we don't have any troubles later. We will be taking some stoppers and stop off the holes that we don't need. This is to reduce the evaporation of the distillate. Again, make sure the stops are greased properly and turn them around a little bit to spread the grease all over the joint. So now we have the apparatus finished. We just add some clamps to the joints to make sure that they don't get loose. It's not necessarily for the distillation head because it's placed vertically. There's not really a chance of it getting off or anything like that. So we just put them on these three joints for now. We will be adding the hose to the hose connection of the jacketed flask. And we can daisy chain the hoses from the receiving flask to the condenser so you get a single loop. If you're doing normal distillations or with chemicals that are not as volatile, this receiving flask is really overkill. You can just get away with the regular single bottom flask most of the time. Or if you don't have a jacketed flask, you can submerge it a little bit in ice water, for example, to reduce the temperature. Next up we have the thermometer. Make sure it's greased and turn around a bit and the scale is facing toward you. Now we will be turning on the circulation cooler. As you can see, the coolant level is rising rapidly. Once on the top, it will go through the hose to the condenser. And from the condenser, it will be going back to the circulation cooler where it will be cooled. You can see here that the temperature is gradually being reduced, starting from 25°C, now it's 16.9. And after a while it will be about -3 or -4, and at that point we will be starting the distillation because that's more than cool enough for our purposes. Keep in mind that if you're using a circulation cooler like us or other cool liquid to cool your equipment, that you get a lot of condensate on the outside of your flask and condenser, which might drip down and damage some electrical equipment. Next we'll be starting our heating mantle at a low temperature and a low RPM for the steering. Make sure you always start slowly. If you're starting with full power, the reaction may go out of hand really fast, and it's something you want to avoid at all costs. We have a really low boiling liquid, so it boils rather fast, as you can see here. You will soon start to see condensate on the inside of the flask, which will work its way up to the distill head and to the condenser. Since this is a really low boiling liquid, it will go really fast like you see here. But because we got a circulation cooler, it's more than capable to condensate all the vapors. Here you can see that the thermometer is on the right temperature for this liquid. Here you can see the vapors working its way up to the distillation head towards the condenser, and eventually will be collected in the receiving flask. Here you can see that our condenser is more than capable enough to condense all the vapors. There's 0 vapors coming out of the reaction flask at the vacuum adapter. As you can see here, we got 0 vapors coming out of the vacuum hose adapter. Because we got such an efficient cooler, we can really distill the product quite fast, as you can see here. We can up the temperature a little bit so it goes faster. Here you have a quick overview of the distillation apparatus doing its work. We're just gonna let it sit for a while and come back after a couple of minutes to see what the level of the distillate is. As you can see, it's filling up quite nicely and quite fast. It's a little bit hard to see because of the condensate of the outside of the flask, but it doesn't really matter. Just make sure when you're performing distillation that you do it outside or in a fume hood. As you can see, the distillation is going on quite nicely. We already distilled off more than half at this point. It's important when you're doing a distillation with a round bottom flask and a heating mantle that you never completely distill off all the liquid in the boiling flask. This is important because if the entire flask is empty, the temperature might rise significantly and will destroy your glassware. Especially if you have a cheap heating mantle with a bad regulator, the temperature can in some cases even be high enough to melt your boiling flask to your heating mantle. So just make sure there's always some liquid left in the boiling flask. You can lower the mantle, turn it off and let it cool down slowly. Here I'm just wiping off some condensate on the side of the receiving flask. You can see how much we distilled over already. Here you can see our end product. After everything is cooled down, you can disconnect the receiving flask and start preparation for storing it in a bottle. Because this product is quite volatile and aggressive solvent, we choose to store it in a brown glass bottle with a Teflon lining in the cap so no gas escapes. It's always important to choose the right storage container for the right chemical, as some solvents might pass through some thin plastic containers or stuff like that. Also, sometimes sunlight can damage the chemicals, so it's handy to store it in brown glass like here. Here we just put on the cap and make sure it's secured tightly so nothing escapes the bottle. Next we will be labeling our product. Make sure you always label your chemicals correctly, as if you don't do that and for example you take a wrong chemical and put it in your reaction flask, really bad things might happen. So make sure you always put on the right labels and the danger symbols and stuff like that. And here you have the end product in the bottle. So that's it for distillation. We'll be going over some tips now that might be handy for you and that we didn't go over in the distillation itself. First off, if you really want a pure product, it might be handy to distill slowly and to get rid of the first and the last couple of milliliters of the distillate. The first and the last fractions can contain some high or low boiling chemicals which you don't want, so it might be handy to just get rid of them properly, of course. Also make sure your glassware is also clean. Some dirty glassware can cause some side reactions that you don't want. Just make sure you rinse your glassware with distilled water afterwards and to dry it completely. There are some special brushes available which you can bend and stuck inside to remove some hard to remove pieces, or alternatively you can add some glass beads or small stirring bars and shake the flask around a little bit with water. That will remove some hard cooked on stuff most of the time. Like I said earlier, when you're using a heating mantle or other heating source that can get really high, just make sure you don't dry up the distillation flask completely. Like I said earlier, this might cause some damage to your glassware. It might get really hot, you might burn your hands, stuff like that. So it's best to just leave a little bit inside and cool it down and then get rid of it later. Also make sure you use the right size joints. There are a lot of size joints in Europe and America and everywhere in the world. They use different sizes of ground joints. In Europe the most common one is 2932, but 2429 or 2440 is also quite common. There are adapters available, of course, so you can connect them to each other, but it's easiest if you just use the native joint sizes for all your glassware. To don't add unnecessary amount of glassware to your setup. Also, when you're using clips to secure your joints, make sure you don't use plastic ones if you're distilling at a high temperature. They might melt, fuse, no, not necessarily fuse, but get stuck to your glassware. It might be hard to remove and clean up. So the best choice most of the time is just to use metal or stainless steel clamps to your glassware. If you're distilling a liquid with a high boiling point, it's also handy to sometimes wrap your distill head and flask in some aluminium foil. This is to keep the heat inside, to help the reaction move forward. Also, if you're using a fractionating column, it might be handy to add some aluminum foil, or if you have some more money to spend, have a vacuum jacketed column. So we hope you learned something from the video. Give it a thumbs up and like if you do. Also, if you have other questions of something we didn't mention here, or you want to see a video of some other equipment we have and sell, or just some regular questions about glassware equipment, please let us know. Maybe we can make a video about it. Most of the equipment used here in the video will be linked down in the comments. And that's it, guys. Hope you liked it, and see you later.